In this video, we're going to learn about Dalton's law of partial pressures. Please take the time to record these vocabulary words into your journal. A gaseous mixture is simply a mixture of gases, and it's going to be composed of multiple different types of gases. So, for example, atmospheric air is an example of a gaseous mixture. It's made up of oxygen gas, nitrogen gas, carbon dioxide gas, water gas, or what we call water vapor. So gaseous mixture is just a mix of gas. Then you have this partial pressure that we use the symbol with a capital P for pressure, and then as a subscript we write the formula of the gas. And this is going to be the pressure exerted by a specific gas. Each gas in a mixture has its own partial pressure value. And then we have total pressure with a symbol again with a capital P, but this time as a subscript we write out the word total, or sometimes you're just going to see the capital T. This is when you add all those partial pressures of those individual gases together and you get a total amount of pressure in the container. So the reason why I point out these three vocabulary words is because oftentimes when we're given word problems, the hardest part is determining which gas law do we use. Do we use Dalton's law? Do we use the ideal gas law? So this is hopefully going to make it a little bit easier in recognizing when you have a Dalton's law problem. Anytime you see the word gas mixture or partial pressure or total pressure, those are red flags to you indicating that this is going to be a Dalton's law problem. And so what is Dalton's law? It's pretty simple. It's stating that the total pressure of a gas mixture is equal to the sum of all the individual partial pressures of all the gases present in that mixture. So the equation is pretty simple. P total or total pressure is simply going to be all those partial pressures added together. And that ... there means that it goes on forever for however many gases you have in the container. So if you have 10 different gases in the container, then you're going to have 10 partial pressures added together. So let's take a look at a few examples. Okay, example number 1. Please do write down the problem. So if you need to hit pause, go ahead and do that so you can record the question. But here we have a mixture of gases. Okay, so I see that keyword, mixture of gases. It's probably going to be a Dalton's law problem. It contains helium, nitrogen, and argon gas. And partial pressures, here's another keyword, are 1.22 atm, 3.51 atm, and 2.43 atm respectively. Calculate the total pressure of the gaseous mixture. Okay, so I know, because I see those key words, we're dealing with a mixture of gases. This is a Dalton's law problem. So I'm going to record the equation from above for Dalton's law. P total is equal to the partial pressure of gas number 1. And now I'm going to insert the chemical formula for gas number 1 in our mixture. And one of the gases is helium, plus the partial pressure of gas number 2, that will be nitrogen, plus the partial pressure of gas number 3, and that's going to be your argon. I'm solving for total pressure, and now I need to insert or substitute in the partial pressures of each one of these 3 gases. And they've told me this right here. 1.22 atm, 3.51 atm, and 2.43 atm respectively. So some of us might not be aware of what that terminology means. What it means when they write it respectively is this 1.22 atm, since it's the first pressure listed, it corresponds to the first gas listed in our problem. So it's 1.22, that is for helium. And so the second atm pressure listed, that's for the second gas in your mixture. So that's going to be your nitrogen. And then the third gas is going to be argon, and so that's going to have a partial pressure of 2.43. And so now I plug and chug into our Dalton's law equation. And I add all those pressures together and I'll get the total. We get a total pressure of 7.16 and the unit is going to be ATM. Now for example number 2, we have a gaseous mixture which consists of water vapor or H2O gas and hydrogen gas. The total pressure is 0.99 atm and the partial pressure of hydrogen is 0.73 atm. Calculate the partial pressure of the water vapor. So again, I'm highlighting those key words. I know this is going to be a Dalton's law problem because I see a gaseous mixture. They're talking total pressure and partial pressures. So again, let's write out our equation for Dalton's law. Total pressure is equal to the partial pressure of the first gas, which is H2O, plus the partial pressure of the second gas, which is going to be hydrogen. And so I am solving for the partial pressure of the water vapor. So I'm solving for the partial pressure of that H2O. So if I rearrange this equation, the partial pressure of H2O is going to be equal to the the total pressure minus the partial pressure of the hydrogen. And now it becomes a plug and chug into our equation. Okay, we subtract 0.99 minus 0.73. And we'll get an answer of 0.26 atm. In other words, the partial pressure of the water vapor in this mixture is 0.26 atmospheres.